All right, everyone, let's look at the so this discussion question for module 9. So basically I wanted to kind of look at, it's the same principles for counting, so combinations and permutations, but I wanted to look at something that I thought would be a little more demanding. So I've given you all the answers. So basically I'm looking for your solutions here. So you already know what the answers are. So let's just go through this step or yeah, piece by piece. So this first one, how many ways are there to arrange the letters in the word if there are no restrictions? So cameraman is a 9-letter word. So if there were no restrictions at all, then let's think about this. So there are 9 places. So if we want to think about this really simply, I mean, how many options can go here? All 9 letters can go there. And then in the second position, well, I have 8 options because I used one. And then so on and so forth. So it might seem like the number of options here are 9 factorial. But what we have to be aware of is the fact that we have duplicate letters. So we have 2 M's that are indistinguishable from each other. Um, so we have to account for the fact that those can be basically, here, I'll give you an example here. Spelling the word cameraman correctly, like leaving it unaltered, is one of these permutations, right? But if I change the M's, you can't really say that's different. The M's are identical to each other. The same is true for the A's here. So I have 3 A's, and let's just say I were to rearrange the A's. How many ways are there to rearrange the A's? Well, there's the way they're in. I could swap any 2 of them. But basically there are 3 factorial ways. There are 6 ways to arrange those. So, this would be a much easier problem if there were 9 different letters. That would just be 9 factorial. But now I have to be aware of the letters here that are duplicated. So the number of permutations I'm going to have, and I should back up a little bit. Why am I saying permutations? I didn't explain why it's a permutation instead of a combination. The key word I'm going to focus on here is arrange. That implies to me that I have some kind of order. So I'm going to go with permutations. So let's write this out. 9 times 8, 7, 6, 5, 4, 3, 2, 1 over 2 times 1 times 3 times 2 times 1. 3 times 2 times 1 cancels here. And then let's make this a 2. All right. So let's make sure that this that I have gives me the number that I told you is correct. And I get 30,240. So this is equal to 30,240, which is what we're looking for. All right, next. How many ways are there to arrange the letters if A's are in the first, fifth, and ninth positions? So I think it's good to kind of organize these. I mean, obviously you don't want to count 360 different possibilities, but we can kind of start by looking at what some examples look like. So if the A goes here, 2, 3, 4, A goes here, 6, 7, 8, 9, A goes here. So let's check off the letters that I've already used. I've used the A, the A, the A. So I don't have any A's left. What do I have left? I have C, M, E, R, M, N. So I have 6 letters left. So it might seem like the number of options I have is 6 factorial. But kind of like the last example, I can arrange those 6 letters however I want, but I have to account for the fact that these M's could be, swapped for each other and yield the same exact thing. So I think my final result is going to be 6 factorial for the 6 permutations. And then I'm going to divide that by 2 because changing the A's is going to give me something identical. So over 2 times 1. 6 times 5 is 30, times 4 is 120, times 3 is 360, which is what I was looking for. All right, next. How many ways are there to arrange the letters if there is exactly one letter between the M's? Okay, so again, I'm going to write out the 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there has to be exactly one letter between the M's. So how many ways are there to do that? So let's put an M in the first position. So if I put an M there, then I think I have to put the other M here. So if I put the M's there, then how many ways are there to arrange the other letters? There's 1, 2, 3, 4, 5, 6, 7 blanks. So there are 7 factorial permutations I can make. But I got to account for duplicates here, so, or for the, repeated letters. So there are 7 factorial ways to arrange them, but 3 factorial of those ways are going to be identical because I have 3 different A's that could be transposed for each other and would yield the same, basically the same object. Okay, so am I done here? Is 7 factorial over 3 factorial all I have to do? Well, not exactly, because this was assuming that the M's are in the first and third position, but they could also be in the second and fourth position, or the third and fifth. So how many different ways are to place the M's? Like, so if you can imagine kind of sliding these M's from as far left as they can go to as far right as they can go, how many places is that? So I think it's 1, 2, 3. Let's just write them all out. 4, 5, 6, and I think one more and I'll run out of room. So 7. So once I place the M's, I have 7 factorial over 3 factorial ways to arrange the other letters. But I got to account for the fact that there are 7 different places for the M's that I could use. So if we write this out, 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1 times 7. Let's go minus sign. Cancel, cancel. So I get a number that I'm not going to try to multiply in my head. 7 times 7 times 6 times 5 times 4. And I do indeed get 5,880. Okay, so moving on to part 4 here. So one thing I wanted to focus on, I see the word arrange in all 3 of these parts, which I was using as my clue to find permutations. So I've kind of changed the game on you here. So how many different 3-letter collections can be made, which contain exactly one M and one A? So am I still looking at permutations? I don't believe so. And the reason for that is I'm just looking at a collection. I'm just looking at a set. And one thing we've said about sets is that, if I have this set, ABC, and I have this other set, CBA, you can't say those are different. A set is just an unordered, basically, collection of things. So do these 2 sets have the same things in them? Yes, they do. I didn't write them in the same order, but they have the same things in them. So I'm going to treat my collections kind of the same way. So because of that, I'm looking at combinations here. So if I'm looking at 3-letter combinations, I'm still going to write out the blanks. So blank, blank, blank. So I want to know how many contain exactly one M and one A. So I've already accounted for those. So what can go in the last blank? So basically what I'm choosing here, and what another word I'm going to highlight here is exactly. Exactly one M and one A. So because of that, I can't choose another M or another A. So I already said I'm looking at combinations here. How many objects do I have to choose from for that last blank? Well, it could be a C, not an A, not an M. It could be an E, it could be an R, or it could be an N. So I don't want to use another A or an M, so those are not options. So I have a combination of 4 objects, but how many am I going to choose from those 4 objects? That is going to be 1. So this will be 4 factorial over 1 factorial times 4 minus 1 factorial. So 4 factorial over 1 times 3 times 2 times 1. I don't know why I didn't write that out. 4 times 3 times 2 times 1. And I truly just get 4. So this number is 4, which is what we said was the correct answer. All right, moving on to the last part here. How many different 3-letter collections can be made which contain at least one M? So operative phrase, or one of the operative phrases here, is at least one M. So we're going to break these into 2, or which I'm not going to say 2 yet. We're going to break this into multiple mutually exclusive cases. So one of those cases, I'll call case A. I'll say 1M. Let's just handle that one first. We'll talk about where to go from there. So let's be even more clear here. Exactly 1M. All right. So how many objects or how many collections have exactly 1M? Well, let's think about this. Let's start building out what else we can put here. So what are our options? So if we're using exactly 1M, I don't want to use another one. So let's write down, like, here's my letter bag, basically. What letters can I choose? I can choose C, I can choose A, I can choose E, I can choose R, I can choose the other A. What was the third A? And I can choose N. So CAERAAN. So you might not see kind of how to approach this using those combination and permutation formulas. And I don't know if I do. So let's just start building things out. So here's what I'm going to do. This is a combination, so order doesn't matter. So that's something I have to be aware of. So let's say this. From here, I'm going to kind of break this into subcases. So I'll call this AA. Sure. I hate that. What to call it? I'll call it big A, little a. And that's going to be the case where I have an M in the first position. I shouldn't even call position because I don't really care about where they are. But what goes in the second position is a C. So what things are allowed to go in this third blank? Well, I use the C. So what can go there? An A, an E. So basically, if I take out the C, it might look like I have 6 options, right? But I don't really, because there's only 4 different things I could use there. So I think there are 4 choices. Okay, so let's reload. What about A, B? Well, that's going to be the case where, these are all that's going to be in common here is that M is one of the things I choose. Now let's say A is the other thing I choose. So now how many options can go there? Now, I'm going to go ahead and remove the C because let's just think about this for a second. What if I put a C there? Now I'm double counting things because I already chose, MCA was one of my 4 options here. Maybe I should write down what those options were. MCA, MCE, MCR, MCN. So because of that, MAC, remember, these are combinations. I don't care about the order. So MAC is the same as MCA. So because of that, I'm going to go ahead and just remove C from, like, I'm not going to look at any more C stuff. I've already dealt with all the combinations that involve C that I'm going to allow. So what else can go here? I'm going to just write them out. MA, and for now, I'll kind of cross this off because we've used it. MAE, MAR. I think I can have MAA because I can take another A. And MAN. So 4 options here, 4 options here. Okay, so let's do this. Let's do our next case. So we did MA, or sorry, MC, MA. Now let's do ME. So for the same reason that I eliminated the C, I'm going to eliminate that A this time. So, and then I'll cross this out for now. So what things can go here? I can have MER. I can have MEA, right? Actually, no, because I already have MAE. So when I eliminated the A, I think I have a good reason to eliminate all the A's because I've already built all the combinations that involve at least an A. So I'm going to take MEA off my list. So I had MER and then MEN. Okay, so how many new options did I just make? I made 2. So 4, 8, 10. All right, so what's my last combination here? M. So I think the last thing I can do here is MRN. So that is 1. So for this, one case here, I have exactly 1 M. This spawned these 4 like sub cases, and all told, I had 11 options. So far I have 11. So now I think I'm moving on to case B. Case B is where I have exactly how many M's? Exactly 2 M's. Okay, so let's look at that. So M, and then I have to decide what goes in this third blank. What's the next thing I'm going to pick? Well, what could it be? I think it could be, so I'm only picking one thing. So it's a combination of, some number of things, and I'm only taking one. So how many things can I choose? Well, I got rid of the M's. So a couple of things here. I said exactly 2 M's, so I don't want to take another M, but I also don't have any more M's to take. So what options do I have left? I have C, I have A, I have R. Don't need to say A again. Don't need to say A again. Well, I skipped the E for some reason. So I have C, A, E, R, and N. So of a list of 5 objects, I'm going to choose one, and that is 5. So I have 11 options for my first case, 5 options for my second case. Case A and case B are mutually exclusive, which means that I add those together to get 16, which is what I want. All right, that is all for discussion question 9.